Salam sejahtera doctor, we are from Group 4 and the topic we chose for assignment 3 is the Bodyfat classification. Our group consists of 3 members who are Asyraaf Danial 284368, Muhammad HADIF 287852 and me FOONG 289851. Now I will present the purpose and objective of our assignment. First, the purpose is to enable the development of classification models that can accurately categorize the individuals into 2 distinct groups. The 2 distinct groups is based on their body fat levels, which are below average and above average. The objective of our assignment is to support the creation of robust machine learning models that can assist in assessing an individual body composition and identifying the potential health risks associated with the body fat levels. By providing a labeled dataset with body measurements and the corresponding body fat categories, the dataset seeks to facilitate the research in the field of body composition analysis and contribute to the health-related applications. Now I will proceed to the description of our body fat prediction dataset. This dataset is a collection of measurements and the body characteristic of 252 individuals, along with their corresponding body fat percentage. The dataset was compiled for the purpose of predicting the body fat percentage based on the provided attributes. This dataset is useful for exploring the relationships between the various body measurements and the body fat percentage, and finally to build the predictive models to estimate the body fat levels. For the target variable of this dataset is the body fat percentage. The body fat percentage of the individual. This attribute serves as the target variable for a prediction task. The body fat percentage represents the proportion of fat tissues in relation to the total body weight and is a critical metric in assessing the overall health and fitness. Here are 13 columns for this dataset which represent the number of features or attributes. For the number of records, there are 252, which also the number of rows on the instance in this dataset. The problem to be solved or the insights aimed to gain. The first is the body fat classification. The primary problem to solve is to build a classification model that accurately classifies the individuals into 2 categories, just like what we stated at the purpose of the assignment, which is above average and below average body fat levels. This task involves using the machine learning algorithms to predict the body fat category based on the provided body measurements. For the feature importance and correlations, we analyze the dataset to identify which body measurements are most informative for distinguish between the individuals with below average and above average body fat levels. By understanding which features are crucial for classification, it can provide the insights into the relationship between the body composition and the body fat percentage. And this also can contribute to the health and the fitness insights. We can explore how specific the body measurements contribute to an individual being classified as below average or above average in terms of body fat. This can offer valuable insight into the characteristics associated with different body fat percentage.
Moving on to the algorithm that we choose, so we will be using the naive Bayes for our dataset. So naive Bayes is a probabilistic classification algorithm based on Bayes theorem, which is a fundamental concept in probability theory. It is a simple and computationally efficient algorithm commonly used for text classification, spam filtering, and other classification tasks, especially when dealing with high-dimensional data. So how did naive Bayes work? So given a training dataset with features or attributes and corresponding class label, naive Bayes calculate the conditional probabilities for each class based on the occurrence of the features in the training data. When presented with a new instance to classify, naive Bayes compute the probability of each class for the instance and assign the instance to the class with the highest probability. So what are the characteristics of naive Bayes? It is simple and easy to implement. Naive Bayes is a straightforward algorithm that is easy to understand and implement. It has minimal hyperparameters to tune, making it an excellent choice for quick prototyping and baseline models. Next, it is efficient for large datasets. Naive Bayes is computationally efficient and scales well to large datasets with many instances and features. It requires minimal memory and processing power, making it suitable for real-time or streaming data application. And the last one, it can handle high dimensional data. Naive Bayes perform well in dimensional feature spaces, making it well suited for text classification tasks where the number of words or features can be substantial. What are the strengths of Naive Bayes? So is speed and efficiency. Naive Bayes is one of the fastest classification algorithms, making it suitable for large-scale dataset and real-time application. And it is good performance with limited data. Even with relatively small training dataset, Naive Bayes can produce reasonable and often competitive results compared to more complex algorithms. Next, interpretability. So in terms of interpretability, the probabilistic nature of Naive Bayes allow for the easy interpretation of result. The algorithm can provide insight into which features are most indicative for of a particular class. And the last one, it is robust to irrelevant features. Naive Bayes tends to be robust to irrelevant or redundant feature as it treats features independently. This characteristic make it less sensitive to irrelevant input, reducing the risk of overfitting. So we will be moving on to the relationship of Naive Bayes and the dataset that we chosen, which is the Bodyfat dataset. So the first one is categorical features. So Naive Bayes works well with categorical features in the body fat prediction dataset. While some features, example age, are continuous, others like gender or body fat categories below average and above average can be represented as categorical variables. Next, independent features assumption. The naive assumption in Naive Bayes is that all features are conditionally independent given the class label. Though this assumption may not hold perfectly in real-world scenarios, naive Bayes can still perform surprisingly well in practice, especially when there are dependency among features that are relatively weak or conditional on the class label. For the last one, suitable for small datasets, naive Bayes is computationally efficient and requires a relatively small amount of training data to estimate probabilities. In the context of the body fat prediction dataset with 252 instances, naive Bayes can handle the dataset well without being computationally intensive. Next, we'll be looking on for the input features. So first one, we have age. So the age of the individual in years. This attribute represents the age of each participant in the study. Next, we have weight. The weight of the individual is in kilograms, so it denotes the body weight of each participant. Next, we have height. The height of the individual is in centimeters. It records the height of each participant. Next, we have neck, chest, abdomen, and hip circumference. So all of these are in centimeters. It represents the measurement of the neck, chest, abdomen, and hip size. Next, we have thigh, knee, ankle, bicep, forearm, and wrist circumference. So all of these are also measured in centimeters. So this attribute capture the measurement of the thigh, knee, ankle, bicep, forearm, and wrist size.
Assalamualaikum and good day to everyone. My name is Muhammad HADIF bin SHUHAIMI. My metric number is 287852. We'll be sharing to you guys of our model evaluation that we have done during the process of building the predictive model. So let's begin. So for the first part is record and evaluate the model's performance using various performance metrics such as accuracy, precision, recall, error rate, and F1 measure. So in this part, we're using a word cloud as our solving tools in model evaluation process. So throughout this process, we just insert all the four ratio that we stated in the previous model algorithm, and the recall display all the result, including the accuracy, precision, recall, error rate, and F1 measure. So by doing this, with the help of Weka, we managed to get all the result, including the accuracy, precision, recall, error rate, and F1 measure value. So forgot to mention about the matrix coefficient have been used as our assistant during the model evaluation process. So the next part will be the explanation of all the performance metrics in model evaluation. So in this part, I'll be sharing with you guys the explanation of the role of accuracy, precision, recall, error rate, and F1 measure as a performance metrics in model evaluation. So for the first one is accuracy. So accuracy is defined as the number of right guesses divided by the total number of prediction. It's used in displaying the properly anticipate the class label of new or previously unseen data. So throughout the model evaluation, our data set shows the result of findings reveals an accuracy of 81.57% to 87.62%. So the next one is a precision. So precision is defined as a percentage of anticipated positives that turn out to be positive. So it shows how many of the positively anticipated are actually positive. So, referring to the matrix confusion, class that denoted yes has the precision values change from 0.834 to 0.9. So for the third one is the recall. So the recall in use model evaluation defined as a percentage of true positives that are projected or enlisted to be true positives. So it helps to in displaying the percentage of genuinely or accurate positive anticipated cases. So with the help of recall, um, referring to our matrix confusion table in Weka, the recall values vary between 0.16 to 0.9 for the below class known as a yes class, while above class for the below class known as a no class, while above class known as a yes class recall values between 0.6 to 0.909. So next is the error rate. So error rate means the overall amount of prediction divided by the number of wrong guesses. So error rate is displaying the percentage of incorrect guesses or incorrect situation in the model. So as a result is the range of error rates ranges found were from started from 12.37% to 19.32%. So the last one is the F1 measure. So the F1 measure known as a symbiotic relationship between precision and recall. So in using the F1 measure, when you need to balance a precision with a recall, balance between the both of this value, this is as an excellent metric to utilize. So based on our data set, using the F1 measure detects 0.17 and 0.88. So for the next part is we'll be explaining about I'll be sharing with you guys our result comparison for different fold ratios that we stated in the previous model evaluation and model algorithm. So in this table, we insert all the fold ratio along with the accuracy, precision, recall, error rates, and F1 measure. Then we did the analyze and evaluate which the one is the best model evaluation along with its explanation. So in this table, we highlighted the fold ratio 20 to 80 and we did the analyzation as the best model evaluation among the rest. So which has been stated in the explanation that fold 20 to 80 has the highest accuracy, has the highest precision value, has the highest recall value, has the lowest error rate value, and the highest F1 measure value. So next one is with explaining the deep why the fold ratio 20 to 80 was the best model evaluation. Alright, in this part, I'll be sharing with you guys all the explanation why the fold 20 to 80 ratio was the best model evaluation. So the first one is compared to their accuracy. So the best accuracy value found lies on fold ratio 2080, which had the highest proportion of accurate prediction, which is 87.6238. So the next one is a precision comparison has the counting the percentage of occasion when all predictions were correct. So fold 2080 had the highest precision value, and the value stated is 0.89 resulted in the most acceptance or the most indoubtable of its positive forecast. So third one is the recall value compared to the other four ratio. The mean positive prediction rate of the model is calculated as the percentage of all true positive cases. Means that the 420 to 80 ratio had the highest or the largest proportion of positive events recorded with a recall value of 0.876. So for the next one is the error rates. So among the error rates of other four ratios, error rate used to identifying the fraction of wrong cases in the models. So for 2080 had the lowest error rates among the others, value at 12.3762, which was defined as the lowest percentage mistakes in classification or the lowest percentage in making a misclassification. So the last one is the F1 measure value. So F1 measure value used to recombine the harmonic mean or the simplistic mean of between value or precision value and the recall value into a single number or value. So the best F1 measure was on full 2080, which was 0.88 as the best accuracy to recall ratio. So a part of that, in our opinion, among throughout this model evaluation with the previous performance metrics that have been used, full 2080 was picked as the single fold ratio with the highest accuracy, highest precision, highest recall value, and highest F1 measure rate of any fold ratio recreated. So in our opinion, it is recommended for we both recommended for the optimal model performance. So in this last part, I'll be sharing with you guys all of our discussion in limitations or challenges that we counted during the process of model evaluation. So one of the limitation or challenges were data limitation or imbalance were detected, and the data containers of our data sets, and we found that the labor noises and human errors might be considered as our limitation challenges. Evaluation matrix selection and the data overfitting and underfitting was enlisted as a limitation and challenges during our model evaluation. So we managed to list all the possible to encounter all those limitations. So first of all, the suggestion of using the cross validation is great in counter of data qualityness, as we can see that as we can manage to regularize the model. So in choosing of evaluation metrics based on the specific problem and business objective during the evaluation matrix selection of the data sets. So in counter of label noises and human errors, so like data set that come along with it has lots of error or imbalance value like row or column or like decimal or single digit number, using techniques like sourcing or multiple annotators reduce human labeling errors. So to deal with that missing data, which led to data limitation or imbalance, impute missing values or investigate solutions such as data imputation will be helpful in counter them. So the last one is the resampling, such as oversampling or undersampling, to solve class imbalance. We resolve the overfitting or underfitting data in certain data sets. So that's all from me and the rest of my group team. So thank you.